to fit a nonlinear mathematical function to a set of data in order to estimate the parameters of the species area curve. So we know from conservation biology class that there tends to be this predictable relationship between the area of an island, measured in hectares or acres or whatever, and the number of species that that island can support. And we also know that model tends to take on a characteristic form that looks like this. The number of species on an island is a function of this constant c, the area of the island, and the exponent, which is another constant, z. C is a constant that dictates the intercept of the relationship, and z is a constant that indicates the slope of the relationship. So this is all fine and good, but in any given ecosystem, we don't necessarily know what c and z are, so that hampers our ability to predict species numbers from area. But what we could do is we or someone else could go out and collect a set of data at a series of islands and measure the area of those islands and measure how many species occur on those islands. And then with this empirical data, we could fit a mathematical function or a curve to those data in order to estimate C and Z. And from that, we could then go out and predict the number of species that occur on an island of any size. So I'm going to show you how to do that today. So we have here data that we've collected from 5 imaginary islands of differing area, you can see, and then we've gone out and counted how many species occur on each of those islands. First, we're gonna do this nonlinear model fitting in Excel, and then we're gonna do the same thing in Google Sheets, and you'll see that it's very similar. There are just a few differences between the way those two programs work. If you have access to it, I would say Microsoft Excel is probably the better way to go because there are more bells and whistles in that program. So the first thing you want to do is select your data, just highlight it, go to Insert, and you can see there are different graph options. The first thing we want to do is just plot the data, so select Scatter. And you can just pick this first option that doesn't have lines, it just has points. And you can see very quickly Excel has plotted the XY relationship between area on the x-axis and species richness on the y-axis. And you can see, much as we would expect, there's this nonlinear relationship between area and species richness. It tends to be progressing towards some sort of an asymptote or plateau as island size increases. So now what we want to do is fit a line to these data and get the mathematical parameters that describe that line. So if we simply click on the data series or really anywhere on the plot, and you'll see that this chart tools section will emerge in the ribbon at the top of the program. Go to layout, and this is where we could insert any of a number of things we might want to add to our chart: titles, axis titles, grid lines, and so forth. But what we're interested in is a trend line. So select trend line and go all the way to the bottom to more trend line options. And you can see just by hitting that button, it automatically by default fit a linear function to the data, a straight line, but we know that that's not really the mathematical function that best fits the species area curve. We'll leave that there for the moment. Go down to the bottom and check display equation on chart, because that's what we want. We want the equation that describes the relationship between x and y. And you can see if a straight line best fit this relationship, then this would be the form of that relationship in the familiar y equals mx plus b linear model form. But that's not what we want. What we want is to fit a power function to these data, because the species area relationship is a power function. So just check power, and you can see through the magic of math that we now have a curvilinear function fit to our data, and it fits it almost perfectly, and we have the equation that describes that relationship. So if you'll note, y equals some constant times x to another constant looks very similar, in fact identical to the form of the relationship we're looking at, that we were looking for. So now we know that C, let me close this, now we know that C is equal to 1.9995, essentially 2, and we know that Z is equal to 0.3011. So we could now use an island of any area we want. Let's say we have an island that's 50 hectares. Let's say we have another one that's 761. We could predict how many species should occur on that island by just typing in the equation. So if this is the area, species should be equal to 1.9995 times, put in parentheses, whatever our area is. Just click the cell that contains the area we're interested in, put the little caret sign to the 0.3011, close parentheses, boom. So it's going to give us a non-integer number, but we could round that to, let's say, 6 species should occur on a 50 hectare island. We can just grab this lower corner, drag down, and in a 761 hectare island we should get somewhere in the ballpark of 15 species. So this is a useful tool that we could go out and use to make predictions at a variety of places, only equipped only with knowledge of the area of that island. Okay, so that's how we could do this in Excel. We'll quickly do the same thing in Google Sheets just to show you.